All right, hey, hello everyone. My name is Josh Morales. I am, let me go, wait, introduce myself. .NET enthusiast. I have over 20 years experience developing applications, websites, and stuff with .NET. I own and run PageInit Solutions and freelance software and web development. And I also am the admin, have started the RGV Devs .NET user group, which I would encourage you all to join or share with anybody who has any interest in .NET or software development in general. We talk, hoping to talk about a lot of stuff like this. And I'd like to thank again RGV Cyber and all of y'all for hosting me, because I know this is a little different from the cybersecurity stuff, but I appreciate you giving me your time and attention while I talk about code and nerdy stuff. So many thanks to Jeremy and the group. Okay, so let's get started. When it comes to AI, obviously, actually, here's our agenda. We're gonna talk about Python. I'm gonna walk you through a whole bunch of demos and the way that the story of AI in .NET has evolved through the years, and we'll look at a whole bunch of code, a whole bunch of demos, and I'll show you how things have changed and how easy it can be to integrate AI into your .NET applications, and why .NET is definitely a contender when it comes to integrating with AI into applications and all kinds of cool stuff like that. We'll wrap it up, and then we'll talk about some more about RGV devs and how you can get involved. So obviously Python was mentioned a lot today, and there's a good reason for that. It's definitely recognized as a primary language for AI. It's great for rapid prototyping, has a rich ecosystem of libraries. It's really easy to get started. The syntax is really very simple. It's really great to, if you're just getting started, just dive in and then just do it. So why bother with C#? Well, I mean, like as I'll show you here, Microsoft isn't one to sleep on anything lucrative, and AI is certainly probably the biggest technological revolution of our time. And so they definitely have adopted as much as they can, as quickly as they can, and being, I guess, an enterprise-focused company. If you're working with a company that is on the .NET stack, or you are, working with a larger company, they're probably going to be using .NET. And it's nice to know that not only is, Microsoft's .NET integration there, but it's pretty complete, it's pretty robust, it's pretty advanced, and it's not that tough to use to integrate with all of the systems. And that's certainly one of the biggest advantage of the .NET framework, is its integration points. So if you're building a website, you're building an app, you're using .NET, you can plug into this stuff and it's just gonna work. And we'll see how that has evolved over the years, and we'll demonstrate how it's become not just a strong contender, but a complete story for integrating AI into your applications. Now, we'll start at the beginning, which is probably not the best place to start, but probably the most complete place to start. At the end of the day, the internet is really just send a request, get a response, and that's how the internet works. And at a low level, that's exactly how we had to do this in the beginning. It's just an API call. You give it the parameters of the stuff that you want it to do. It gives you a response. You parse that response, and then you do something with it. That's basically the internet. But the problem is, obviously, everybody has their own language. Everybody has their own APIs, parameters, response structures. And unless you want to build one for every single provider, you need a better plan. But understanding how it works underneath the covers is important. So I definitely want to show that. And obviously, you have complete control over the entire, communication stack of talking to an AI model if you do it this way, but you got to do it all yourself. You can't just like turn the faucet on and have the water come out and go down the drain. You literally got to lay the pipes going from the street to your house to make it work. And that's kind of the analogy of working at this level. But it does work, and I'll show that here in our first demo. Is basically just brute force HTTP client. We're going to be like, issue a call, give me the response, and I'll do something with it. And so let me pull up my first demo here, and I will be sharing the code for this if you want to play along later on. but let's take a look at what we're doing here. So let's make this smaller. Is that readable? All right. So at a high level, what we're doing here basically is I have hard-coded a prompt simulating a customer who has a problem with their backpack that they bought. And I have obviously a bunch of configuration settings where I'm going to specify which model I'm using. I got an API key. This is the way that .NET configures their settings. Pretty straightforward. So what we're doing now is we're going to basically use the internal HTTP client, which is the wrapper for sending and receiving requests over the internet in .NET. And in order to do that, we'll take a look at this code here. And we have to construct all of the parameters manually. So you can see here for the OpenAI, which is ChatGPT, I've got to create a JSON object. I've got to make sure that I use the right name that conforms to their requirements. I have to make sure that I put in the role. First, I give it a system prompt. I tell it what it is that I want it to do. Then I send it the role of the user, which is the actual request. And then I send, oh, here's a customer sending them feedback. Give them a short empathetic response. And this represents the input that the person is sending. And so we get the OpenAI request. We literally construct an HTTP message, a raw HTTP message. We post it to the URL for OpenAI. We specify all of the headers, all of the raw data, send our API key to authenticate our request. And then we have to parse the content. We have to know that the format of that content starts with a choices result, then a messages, then a content. Then we can finally get the final value. And then we can finally send the response to the user. Now contrast that with the Gemini version, which is similar in that we're constructing an HTTP request, of course, the same way, but the parameters are completely different. This one, it starts with the contents of a JSON array. It's parts with a text. So it's a completely different format. And if you don't know that format, it's not going to work. It's going to reject it and say, I don't know what you're saying. And then, of course, when we get the response, this has a completely different header with an API key in the header that you send it as an authorization, whereas this one used the bearer token, totally different. And then the response structure is obviously going to be different as well. Candidates, content, parts, text. You have to know all this in order for it to work, or it ain't going to work. And then finally, we get the response, and then we can write it out and see it. At the end of the day, it looks the same to the user. The user doesn't care. But you, as a developer, have to know all of this, or it doesn't work. So if we run that, the first thing it's going to do, here's my inquiry. Bought my backpack and the zipper broke. So here's OpenAI's response. Like, oh, I'm sorry. Tell me more, I'll help you. And then Gemini obviously is going to have a similar response, like, I'm so sorry. Gemini's a little more terse, but at the end of the day, it works. But look at everything that we had to do in order to make it work. And God forbid these APIs change or break, you're out of luck. So, of course. So, Microsoft's response to that was to create something called Semantic Kernel. Semantic Kernel was a higher level framework to integrate AI into .NET applications and also introduce orchestration capabilities so that you can, instead of just sending a bunch of raw prompts of like, here's my problem, get a response, and then send it to the user and just basically just make a chat client, it gave you the ability to kind of orchestrate requests in a more natural language way. And we'll see that. But it's basically was just specifically designed to put an abstraction layer over that. So you never have to do that ugly code ever again. And so there's a lot of features and benefits obviously here to this. The orchestration layer basically just abstracts everything down to a prompt. So you as a developer don't have to worry about that plumbing or the low level, code. You can actually talk to it, your request in a bit of a higher level, natural language. The learning curve is definitely reduced because you don't have to worry about parsing JSON responses manually. Definitely more reliable. You can use a lot more TriCat, language framework elements to make more robust code. And it's actually dog-fooded. This is what they use to build Copilot themselves. So you're using the same thing that they did to build the thing that you use when you open Windows and ask for AI. So it wasn't just like some rinky-dinky platform that they threw out there. It's the same one that they're using. So it's definitely very robust, very powerful. And as we'll see, makes it a little bit simpler to kind of interact with those AI models. So we'll go ahead and go on to demo 2 here. And this is semantic kernel, and I'll walk you through some of the code here. Here we're importing the semantic kernel from a NuGet library. If you've never heard of NuGet, but you're familiar with NPM, NuGet is basically .NET's version of NPM. It's just a big package library of stuff you can bring into your project and use. So semantic kernel is one of the packages that they released to support this platform. We get the configuration settings, we get the API keys, and here again we have that same prompt. But rather than constructing raw HTTP requests, as you can see here, what we do is we initialize the kernel, the semantic kernel, and we tell it, give me an OpenAI chat client. I'm not telling it I'm going to give you a raw request. I'm telling it I want to chat with an OpenAI. Give me that client. So now we've got an actual model that exposes methods that we can use to communicate with that model. So we've got 2 prompts that we define, again, using natural language. We're telling it what we want the agent to do in natural language, and we're telling it what we want it, how we want it to respond when it gets that information from the customer. And so we create a function from the prompt for analysis. We create a function from the prompt for response. And then we tell it to go ahead and invoke that command from the customer's input and do something. So rather than constructing a raw request and trying to figure out what it is that it's doing and trying to turn that into a response, we basically just tell give me a client, here's what you're supposed to do, and do it. Far simpler, right? So let's take a look at what the output looks like with that. We'll start a new instance of that. Bring that over. So once again, order the same prompt, order a backpack, and it broke. You can see this is what it gets back. This is what the semantic kernel sees. It extracted the sentiment automatically. I didn't tell it to do that. It constructed its analysis. It identified the product that the customer was asking about, and it just identified the summary of what the customer requested. And so now we can generate a context-aware response from what the customer said and say, hey, I'm sorry, blah, 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 somebody will be in touch. So it further automated that process and simplified what you as a developer had to do to make it work. And it's pretty cool, but there's an issue. As you can see, when we created it, we specified OpenAI explicitly. That, again, like I said, is ChatGPT. What if you want to use Gemini? What if you want to use Claude? What if you want to use your own internal model using Ollama or something? You're going to have to change the code every time you want to change the model. So Microsoft, being the smart people that they are, decided that we needed to go further. And that was by standardizing this process using extensions.ai. And this is a collection of libraries that basically extracted all of those, like that chat client and the responses and all of the different building blocks that you need to interact with a model, and made them generic. So now instead of asking for an OpenAI model, an OpenAI chat client, you say, just give me a chat client. And that chat client, in my case, is going to be OpenAI. But it might be Gemini. It might be Claude. It might be whatever I want. It doesn't matter, because as long as it conforms to that abstraction, it's going to work. And I'll show you exactly what that means when we look at the code. But this was a really powerful thing that they decided to do, because it basically gave the framework the ability to further abstract the interaction with models, so that you didn't have to rely on, model specific libraries like OpenAI's SDK and Gemini's SDK to build your software. as long as you built around these abstractions, your stuff was going to work, and you can plug and play and swap with any model. And it works perfectly as the underlying layer of semantic kernel. It's basically what drives it. They just kind of pulled it out and said, hey, you can also use this without having to orchestrate the entire semantic kernel layer. You just want to call a chat AI client. Well, then you can just call a chat AI client. You don't have to construct all of this infrastructure around it. So it laid a foundation for what we're going to see. It empowered a really robust integration. But for now, let's take a look at what this actually means. And so we're going to look at integrating with these extensions AI to kind of give a more abstract but low-level interaction with these models. So let's pull up the next demo. And in this case, what we're doing is we pulled in, obviously, all of the same NuGet packages for that particular model. There is no reference to the semantic kernel here. We're working straight with the abstractions. Same prompt, everything's pretty much the same at this point. But what's different is, where are we? Check it out. Okay, so here's where we actually initialize everything. The first thing that we do is we're going to configure the services by adding this interface called iChat client. And if you look at the interface, the namespace of that is the Microsoft extensions.ai.iChat client. So it's a very generic chat client. It just means I am a chat client. And it's up to the models to implement their version of that. So there's an OpenAI chat client that inherits from this, the Gemini chat client that inherits from this. As long as they implement this interface, it's going to work. A new model comes out tomorrow. As long as they implement this interface, you can plug it right into your system, and it's going to work. And so here we get, a lot of this is just the .NET syntax and the way that it does things. But you can see here, I'm just getting the configuration. I'm getting the API keys that I need. And I'm registering both. I'm actually registering two clients. I'm registering my OpenAI client and my Gemini client. But they both are registered as the same iChat client. So in the eyes of .NET, doesn't care. They both are the same thing. And so when we get the client, we basically just say, well, which one are we working with? The configuration is going to tell you that. So if we go to the app settings, we can see here there's an active provider. So this is just me giving it a configuration setting and saying, hey, when you run, go ahead and do it with OpenAI. If I wanted to, I can say, do Gemini instead, Gemomo. That's it. It's gonna run its thing. It's gonna do its thing, and it doesn't care which model you're using as long as it conforms to that spec. It's gonna work. So let me run this and show you exactly what it's doing and why this is so important. Come on. All right, so the first thing you can see here is that it loaded my configuration with OpenAI, because that's the provider that I told it to use by default in that configuration setting that I showed you. And so it's sending the request for the same, my zipper broke, whatever, and it's getting the response, and it's not working because I forgot to include the thing. Let me do that right quick, sorry. Include that, and then make sure that I copy it. And then let me publish, run it again. There we go. So it's selected the OpenAI, it's sending that request to OpenAI, and it's doing the same thing that it did before. Something broke, I need to respond. Sounds great. Okay, I'm sorry, we all saw this already. But here's where it gets cool. If I go into the app settings and I change my provider to Gemini, it's using the exact same code that it did to do this, but now it's initializing with Gemini. So it's parsing the same exact request. It's parsing the same exact, well, not the same result, but the response that it gets is doing the same thing with it. And now we get a response from Gemini's version of the thing. So you see, the same exact code that I wrote to do whatever it's doing, I swapped in the model by just changing the provider name in my configuration. And that's the power of .NET, is the integration, the dependency injection. It's all just built into the framework. And if you build your application with that, you get this kind of power. That's pretty cool. So, but there's yet still a limitation with this, and I'm going to show you here. One of the things that we are doing that I added to the code here to demonstrate the limitation is, now that we got the response, I want to tell it, okay, help me. Where did I do the response? Okay, I can't find it. But basically, I'm telling it, now that you know that I have a problem, I want you to help me replace it or something. Like, what would you do as a customer? The AI has said, oh, no, I'm sorry. What do you want me to do? You tell it, give me another one. Send me a replacement, right? So that's what I did. I'm like, okay, send me a replacement. So when I ask it to send me a replacement and I want it to give me the order number or whatever so it can continue to help me, let me let it run and I'll show you what I mean. Come on. You can see here that it generated a response and it came up with this order number here that it completely hallucinated. The AI has no idea who you are. The AI has no idea like what order number you place. You didn't give it to it, so there's no way that it can know, but you're telling it, respond with help with the order number and help this customer. But it doesn't know what the order number is, so it just made one up. And so this is a problem, obviously, that we need to overcome. And how do we do that? How do I tell this AI, find the order number? The AI has no idea, it doesn't have any connectivity into my system. It doesn't connect to my database. It doesn't know how to retrieve an order number based on the customer. So how do I tell it to do that? Well, let's find out. So one of the cool things that Microsoft has done recently was to create this platform called AutoGen, which was a Python system that allowed you to create multiple agents and orchestrate them together and call external functions and have them all basically be able to communicate with each other in a very simplified fashion. And it's by leveraging this platform that we're able to do it. It's basically multi-agent collaboration. So instead of just making that single agent that we made that says, okay, help this customer, we can also make another agent that says, okay, here's how you look up an order number. And we can be like, the first agent says, oh, my customer needs help, but I need their order number. Well, that agent can now call the second agent who knows how to get the order number and say, give me the order number. And now he can get it back and help the customer. So AutoGen was this kind of thing that they built so that you can prototype and make these things very quickly. And they very quickly realized that we need this, obviously, in .NET. So they ported it to AutoGen.NET pretty quickly. And now this is built into the framework where you can use that platform of AutoGen to create multiple agents that can communicate with each other. And by including these libraries, you can build these things yourself. So it enables complex workflows, long-running tasks, and just enables you to do all of this kind of stuff that we were limited in by just doing, you know, a straight chat client. So let's see what that looks like. We will go into demo number 4. So we've imported the AutoGen library. And what we're doing here in this case, once again, same prompt, same issue. And what we're doing is we have this order history service. And in this case, this is just a dummy service. I'm literally like, if you look at the function, it's basically saying, if they say their name is Alice and they have a backpack, just return this exact order number, just for dummy purposes. Obviously, in a real world scenario, this would be connected to your database backend, be able to look up based on the customer name, customer, whatever they give you. But the cool part is that it's getting the customer name and the product name, and it's extracting that smartly from the arguments that are being pulled in, that it smartly is able to identify using a natural language. I don't actually have to tell it, like, look for this parameter and parse the parameter and figure it out. Like, it knows how to do that. So as long as the customer speaks in a natural language, says their name, says that their backpack, this agent is capable of extracting that information from their natural language input. And it also knows that by registering this function, that it knows, hey, here's where we register that function middleware, and we tell that function middleware, point to this dummy function right here, get the order number. As long as we tell it what to do, it's going to do it. It knows what to do. And of course, you want to conform to the right syntax and setting it up, and you can look closer at the demo of how that's set up. But as long as you wire it all together, it's going to know exactly what to do in a natural language to give the customer what they need. So let's run this and see what that looks like. So once again, customer, Alice, backpack broke, agent, and it never works the first time for some reason. I always have to, let me try that again, sorry. Let's see if it does it. If not, I will just force it. No, still doesn't do it. Why did I know? What did I do differently last time that made it work? Gemini 5. You know what? Forget it. I'll super hardcode it. No matter what you do, give me the order number. There we go. So now the agent has extracted their information, sent it to the other function, and now the function was able to get their order number. So now, as the customer, it's like, hey, you found my order number. So it says, hey, that's the right order number. Send me another one, right? So what does it say? It says, like, I don't know what you're talking about. What's your name? What's your order number? It literally just found it. I literally just told it who I was, what I wanted, and it told it what the order number was. And yet when I asked it for a replacement, it's like, who are you? What do you want? Why is that? Was because although AutoGen does give you this orchestration of being able to communicate between agents, it is lacking in statefulness, where the agent can remember what you're talking about. And so this is where it all comes together. Microsoft Agent Framework was actually just released October 1st of this month, exactly a week ago. And it is, I think it's still in preview, if I'm not wrong. But basically, it is a culmination of everything that I've just taught you or shown you into one framework. It takes the orchestration and stability that Semantic Kernel gave us that we showed with the multi-agent, prototyping and quick integration that AutoGen gave us, all built on the abstraction layer of the extensions AI into a unified framework that further abstracts this communication so that you can build your stateful orchestrating agents with a single unified platform. So this is where it all comes together, and why .NET's kind of cool, because it always leads to this kind of stuff. And you can do it in Python too, if you like Python. So this Microsoft Agent Framework supports both C# and Python. So if you like Python, you don't like Microsoft or whatever, you still use it. Again, you get state management for long-running processes, checkpointing. You get thread safe stuff, and again, supports both C# and Python. And you can build your entire application where you are just building an agent. You're not building APIs or services. As you can see, how much more abstract and how much more clear the code is based on compared to everything that we looked at before. So let's take a look at how that compares here. We'll open up demo number 5 and see we pulled in our agents, the extensions AI upon which it's built, and let's walk through it. So first, obviously, configuration, get the keys, all straightforward. Here's where it gets interesting. I've got a collection of services that I'm going to tell the agent that I need it to know how to use. So I've got to create a support ticket. And again, this is all just dummy stuff. I'm just telling it, like, if I take a look at this code, literally just generate a random number with this TCK prefix. The replacement service is going to get a tracking number with a random thing. Obviously, then in the back end of your live service, it's going to do a whole bunch of stuff. But at the end of the day, it's going to return a support ticket number and a tracking number. So we just tell it, there's my support ticket service, there's my replacement service, and now you, as a plugin, register those services so that you as an agent can talk to those services. Then I tell it in the instructions, this is where it gets interesting. Again, natural language, you're a customer agent, you're supposed to help by using your tools, and here's where it says, remember your information across conversations, customer name, product name, order numbers, a ticket ID. If they report an issue, here's where I tell it, use the create support ticket function. Literally just give it the name of the function that I want it to use, and it's going to know what to do. It's going to give it a ticket number that you must remember, ticket ID that was returned. If they want a replacement, use the confirm replacement function that confirm replacement function that I showed you, that you remembered, and then gives you a tracking number, let the customer know, ask them if they want an email, and if they do, respond with everything that you just told them in an email. And in this case, I'll put the email to the screen. But the point is that what it's doing is it's going to go through all of those functions, and not only is it going to get that data, but it's going to remember that data. So as the customer continues to talk to the agent, it can maintain that context and take them through the complete journey of getting their support. And at that point, all we got to do is, and here's what's pretty cool. So I get the OpenA client, and then I get the client with the information that I want with the model, which is, I think, GPT-5 Mini or whatever. I tell it the instructions that I want it, that I showed you. And then I tell it the tools that I want it to use, which I showed you. And then the service provider that is basically just building it using the framework. And here's where I just tell it, create a new conversation. That's a thread. Just create a new conversation and maintain it. This is the object where we're going to store the essence of that conversation. And as long as the customer hasn't said exit, it's going to loop through and just, as long as the customer hasn't said exit, it's going to loop through until it finishes doing what it's doing. So I'm not telling it, go fetch. I'm not telling it to do anything other than listen and respond. So user input, respond. Respond with whatever the agent said, write it to the console. That's it. That is the entirety of the agent definition code. Create a thread, run it with whatever the user said, write it out. 3 lines of code. Let's see what that looks like. So the first thing is, I'm going to tell it, my name, Josh, and I am having trouble with my Lenovo laptop. My order number is 11235. So the agent is going to receive that request, and it's going to run through it. It's going to extract the name, the product, the model, and the order number. And it's going to send that to the fake service to create a support ticket and get the ticket number. And you can see it. There it is right there. There's the prefix that I told it and the random string. And so now it not only did it get that, but it remembered that my name is Josh, that I bought a laptop, and that there's my order number. And so I'm like, oh, blah, blah, blah. Do you want to go through the troubleshooting? I'm like, no, send me another one. And so now it again, like I said, it just took my response, sent it to AI, and gets a response back, and it's going to show it to me. But because I gave it that context, it knows that it needs to send that same information to the tracking system to get the tracking number and give me a replacement. So now that it came back with a response, it still knows who I am. It still knows my ticket ID, my order number, and it has given me a tracking number for my replacement. So I'm going to get my new laptop, and if only all customer service was this easy, I am going to, yeah, so it knows what I'm doing. Now I'm going to tell it, okay, you want an email confirmation email? And I'm like, yes. Give me a confirmation email. And so I didn't have to give it an email template. I didn't have to tell it, you know, parse in the, here is your order with the order number and your name and blah, blah, blah. I just said, send them an email with this information, do it however you need to do it. And so here it is. Here's the subject, replacement, with my order number, my ticket number, my name, the product, the estimated delivery, tracking number, everything it remembered totally with just 3 lines of code. So now here's what another cool thing I want to show you. If I exit this conversation, what I'm doing in the code, just for fun, is I took that thread that, remember, we had the conversation stored in, and I saved it as a serialized string of text. And I am writing that string of text to a file, and then I saved it to the file, and now I'm going to open that file and reload the conversation into a new thread. There's a completely different thread that I initialized from the copy of the text that I saved, and I passed that resume thread into my agent. And so if I look at my thing here, it says it saved my thread to a file. So I'm going to open that. And here is the contents of that file. So this is everything that the agent is using to maintain the state. So you can see there's the name of the agent, there's me, there's my laptop, everything that it sent to me, everything I've said to it. It has the complete history. And why is this important? Because by saving it to the file, reading that file again, and passing that same thread back to the agent, I can now resume a completely different new conversation with that agent, but I can tell it, summarize everything we just did. And because it has that context that was resumed from the thread, it knows absolutely everything that we did and is able to give me a summary of not only what I reported, that I got a replacement, it sent it an email, it knew everything. So this is like a completely new conversation, but it kept all of the context from the previous one. And so you can save your chats and resume them months later, and all of this is built in, and again, with just 3 lines of code. Initialize the agent, pass it the thread, post a response. And that's what the Microsoft Agent Framework lets you do. Very cool stuff. So yeah, just a quick recap of what we learned, and then we'll talk a little bit about how you can dive deeper with into .NET. Started with the raw HTTP calls, proprietary SDKs, really low level stuff. Powerful, you can do whatever you want with it, but it's a pain in the butt for sure. Semantic kernel gave us some abstractions that we can use to certainly make things simpler, and extensions AI gave us an abstract layer that we could use to integrate with multiple models in an easy way. But it wasn't until we got with AutoGen.NET that let us make collaborative agents, and then finally the agent framework that allowed us to streamline this process into an application that we can actually focus on building the delivery that we want to send to our customers rather than just the code to interact with the models. So, in conclusion, .NET isn't just keeping up with AI. It has a mature, complete professional ecosystem for every step of the AI journey. And yeah, so if you want to learn more, I've got these great resources on every one of these elements, for semantic kernel to extensions AI, AutoGen, and definitely the agent framework. Like I said, it's in preview right now, but it's maturing quickly. And the code, I'll post a link to the sample demo that I just demonstrated, so you can pull the code down and use it. You'll need your own API key, obviously. but you can run every one of those. And before I finish, I do want to invite all of you again to join RGV Devs. It is a .NET user group that I'm trying to start where I'm hoping to talk about all kinds of really cool nerdy stuff like this with .NET, not just AI, app building, web building, all kinds of anything having to do with .NET, C#, Azure, Microsoft Stack. You want to learn more or just have some fun nerding out about that stuff? Come check out our website or join our Facebook group, join our mailing list, and spread the word and join the fun. And yeah, so presentation resources are there, including the GitHub repo for the code. If you have any questions, feel free to reach out to me, and I'll be happy to talk .NET with anybody anytime. Thank you.
Anyone in the room have any questions or anything? I was gonna bring the mic over there so people can hear you online.
Thank you. Okay, so first question. Everything you showed us right now, by the way, really good presentation. You did very well. I liked it a lot. Everything you showed with the C# and the .NET, that's becoming done in Python too, right?
Yes, absolutely. This
Okay.
is Microsoft .NET integration point story for AI. So there isn't anything that they're doing that you can't do with any other platform. It's just the way that they are enabling .NET developers to interact with these models.
Okay, so it's like .NET friendly for .NET developers.
Exactly. It is the .NET story for integrating with AI.
Okay, awesome. Okay, and then another question. I know you mentioned this, but you use like OpenAI's ChatGPT, and then you use Gemini too. But I was wondering if it worked with like a model hosted on like Hugging Face.
So it depends on whether or not how you're running it. So for example, if you pull, like if you're running Ollama on your local server, there is definitely an Ollama implementation of those abstractions. So just like there was an OpenAI client, there was a Gemini client, I'm positive there's an Ollama client, and then you can just point it at your local server. So I've never used Hugging Face, so I don't know if it operates in a similar fashion where you just need to give it an API key. But like with Open Router and all of that stuff, as long as they have an abstract implementation, or rather an implementation of that abstract layer, then it's plug and play, for sure.
Okay, and like you just had your API key, and it was just there, and that's where it pulled like the actual like AI logic from. It was just that API key, right? Like you had the API key in your secret file or whatever, and it used that key to call to OpenAI, right?
Yes.
So
you
like,
configure it with the API key, and then it's going to do whatever you want.
Okay. So like, if you had like an API key to your Ollama instance, for example, and it had, like you said, the same level, like that same framework you said, or interface for the abstraction, it would work theoretically, right?
Yeah, as long as you wire everything in the same way, everything is plug and play. And that's the cool part about it, is that you don't have to be a OpenAI expert or a Gemini expert. You know, if you build against these abstractions, you can plug and play and swap out any model. It doesn't matter as long as it conforms to that standard.
Okay. And another question I wanted to ask, I know you mentioned AutoGen, and then after AutoGen came MAF. Between there, you mentioned how AutoGen wasn't stateful, and then how MAF became stateful. Like you started remembering like, your name and like your order number and all that. I just wanted clarification on what was the difference between AutoGen and MAF that made it stateful.
So MAF isn't necessarily a competing technology to AutoGen. It's more of a unification. So it is taking those libraries of semantic kernel and AutoGen and basically combining them into a unified framework upon which you can build your applications. And it did kind of come from that, like AutoGen did have you can use memory, but for like long running tasks, if you had something that needed to maintain state across a really broad application, it's not that it couldn't do it, it just wasn't built to do it. And so but semantic kernel was. And so by combining these two systems together, the framework allows you to kind of just tell it what you want to do, and underneath the covers, it can either instantiate through AutoGen, through semantic kernel, through the abstraction layers, whatever it needs to do, it's going to do it. and all you have to do is tell it, okay, I want memory, I want state, just take care of all of that for me.
Okay.
So yeah, it wasn't necessarily replacing it as much as it was integrating it and completing the story by merging it together into unified platform.
So like it like builds upon AutoGen rather
Yes,
than like.
absolutely,
yeah,
exactly,
okay,
yes.
okay. I think that's all my questions.
Cool.
Anybody else?
Any other questions?
So you started off with the raw queries, and then you introduced semantic kernel. Is Microsoft in charge of making keeping semantic kernel APIs mirroring what, like, let's say OpenAI makes a change to their API? Is it Microsoft's job to make sure that semantic kernel is compatible with whatever changes OpenAI made?
Yes and no. Semantic kernel is maybe Microsoft, and it may be somewhat proprietary, but I would be surprised if it wasn't open source. And the thing is to remember that semantic kernel's platform is the abstraction layer upon which the model builders would create their SDKs on. So I don't know whose like quote unquote job it is, but if the ownership of the implementation for OpenAI's semantic kernel, I would expect to belong to OpenAI. Because the standard is in semantic kernel and says, here's what you need to do in order to conform with semantic kernel. And then OpenAI needs to be like, okay, let's make sure that our SDK aligns with that. So if an API changes at OpenAI, that OpenAI's version of the SDK needs to make sure that it's updated so that semantic kernel can continue to use it without breaking.
I see what you say. So, like, semantic kernel is not necessarily a monolith. It's just like a pattern in which.
Yes,
like,
exactly.
Okay.
Exactly.
Okay, that makes sense. Can't think of anything. I was really interested in AutoGen. I think that's super powerful. And then so when you have, okay, so in AutoGen, a lot of the stuff you showed us was simulating as if we were making call outs, right? So like those functions, like, can you go back to the code on, because I saw, and this is partly me not really understanding C#, but you had like some singleton interfaces. And I was interested, are those supposed to simulate functions wherever your AI agent lives?
I'm trying to find what you're talking about.
So a good example is the whole what was it called? Like an ID, a purchase order ID.
Mm-hmm. Where did I register? So, all right, the singleton, I don't think that was this one. This is a middleware into AutoGen, which is a little bit more aligned with the way that .NET Core operates. They use more of this kind of approach. I think the singletons were
Might have been in demo.
extensions. I don't remember. That's too much code. Don't remember where I did it. All right, here.
There
So,
you go. So
yeah.
so that right there, the iChat client. Well, actually, no, that wouldn't be. Yeah, that okay. So that's like a public, because I saw you had a function at the very bottom, right?
The one that simulates the that pretends that it's actually doing something.
Maybe. You know, I think it actually might be demo 5. Where was it that you had like the different functions that could be called? Like if you call a function, then it performs the actions inside of that.
Okay, so there's two. So the first one, AutoGen, was the one that demonstrated how you can call an external function. So there's this order history service where it's like get the order number from you define this contract, and this is just like the interface contract that AutoGen uses in .NET. Like if you want to register your function, you just need to make sure that you do it in this way. make a function contract, tell it what it is, tell it what the parameter names are, and then point it at your function. So here's my get order number function where I tell it, if they're Alice, here's the order number, and just like, that's it. So you register that into the middleware here by saying, okay, here's my function contract, here's the name of it, here's the parameters, and that's how it knows how to call it. So the function map that we register the middleware here is where we actually tell it, okay, now that you have the customer name, now that you have the product name, go ahead and give me the order number. So it's kind of like a Lego system. You've got, here's my Lego, here's my thing I want to plug into the Lego, and then there's like a machine in the middle that says, okay, where do I get the Legos? Over here? Okay, let me go get it, plug it in.
Oh, got you. Okay, it's kind of acts like a controller in a sense. Like
Exactly, yes.
like okay.
And then with the MAF, it's a little bit different in that maybe this is what you were talking about. When
Yes.
we basically just register, and this is like framework stuff. This is .NET Core, like framework registration of services. And so we're just telling it, here's everything that you need to know, like just discover it. And that's where these kind of names, you see how this create support ticket service aligns with this create support ticket naming. And so, and the replacement service also aligns with so the confirmed replacement aligns with the name of the function down here for confirm replacement. So it does use these kind of conventions to discover that stuff. I believe you could probably be more explicit if you needed to, but I mean, I don't know why you would when it does it for you. So
Those declarations that you have there, right now, I guess the referencing code is within the same file, but let's say, like you didn't have the code, could it be like a third party or something? Almost like an API call out or something?
well, absolutely, because
possible?
I mean, you do need to register the code the function that it's going to call, but that function could call anything. I mean, it could absolutely do an API call to some remote service and then just pass that data back to the agent. So, and that's exactly what it's supposed to do. I mean, in this case, I just hard coded, give me a fixed string, but right here where create support ticket, you absolutely would like, call your support API to generate a ticket and then return it to the thing. So absolutely, that is definitely the way it's supposed to work.
Okay, cool. Yeah, I was like, I feel like that's how you, but okay, that's really powerful, man. That's pretty cool. Okay.
Cool. Any other questions? Awesome. Thank you.
All right, thanks a lot. Appreciate it.